Good morning all. In the previous session, we have discussed regarding the experimental law of Coulomb. Okay, let me just revise what all we have seen. We have seen what is an empirical law. It is on trials and on experimental observations, some law is defined. That law is called empirical law. Coulomb's law is one such empirical law. And then you have seen the experimental setup, what Coulomb experimented. Okay, he used two spheres with some separation and the using different charges. He observed many things by experimentation, and he concluded that you have seen in the statement, electrostatic force between 2 point charges q1 and q2 separated in a space is directly proportional to the product of their magnitudes and inversely proportional to the square of distance between those two charges. And as force is a vector quantity, the direction of this force is very important. It acts along the line joining the two charges. We have seen with this definition, we have arrived at the force equation. F is equal to this 1 by 4 pi epsilon naught q1 q2 divided by r square. This is a simple form. We have not specified direction here. In order to get the direction, we are making use of a suffix r cap as the unit vector, and the direction of this depends on the sign of the charges, whether it's a positive charge used or the negative charge. Okay, in order to see the vector form of the Coulomb's law, we have made use of this particular figure. In this, we are calculating F2. F2 is the force acting on Q2, force exerted on Q2 because of the presence of Q1. I had taken the example of two friends trying to drag the rope. Okay. With this example, we have seen that F2 is 1 by 4 pi epsilon naught Q1 Q2, and this distance R12, what is given here, R12, it is this distance between Q1 and Q2. Observe the force F2. If you see, this is the origin point Q1 and Q2. This direction is from origin to Q1. This is from origin to Q2. So there has to be a continuity in order to apply the vector triangular addition, vector addition. This direction is in this way. So take the continuity. If the direction is like this, on the same direction, along the same direction, your force exists. So this line joining direction is important. What is the line joining direction? It is in this way. That's why it is like this. One more thing you can observe, we have already seen before this some signs, the conventions used. Here only I'll tell you. If there is a positive charge, the lines of force acts outward. Okay, they diverge. This we can observe here in the considered Coulomb's law. The direction is outward, so it is a positive charge. Hence, if you observe, we have considered both positive charges. So it's vice versa. The direction, this and this, they should match with each other. With this, we have got this as the force F2 and unit vector in the vector form. Okay, and this is only if we consider two charges. If there are many charges exist, okay, then we have to consider the force existing between each of these charges. Take this as one charge, the force between these two, force between these two, force between these two. You have to consider all this, and all together all the forces should be added, vector sum. This particular thing you will be dealing in detail while solving the problems. Okay, you'll understand this concept, how we add the forces. This is force, as a note I have shown you the Coulomb's law, F12 and F21. Okay, F12 is the force exerted on first charge due to second charge. This is reverse, force exerting on second charge due to first charge. So accordingly, from the figure using the vector addition, we have seen F12 is this equation. I will not again go into details. You can just recall this previous session what we have dealt. With these two, if you observe both the forces, the sign is different. However, the magnitude of these forces are same. So they are equal in magnitude, but direction will be opposite for both the forces. It is the same, like if two friends are standing, if this person wants to drag the rope towards her side, the other person wants to drag the rope on the other side, on her side. So obviously the directions of forces will be opposite. Okay. Now coming to the next topic, today we are going to deal with electric field intensity. I have not written here, it is denoted as capital E. Okay. Again, electric field intensity is also a vector quantity, important. So whenever we are formulating this electric field intensity, we have to consider the direction, just like the force. Before that, you just see what is a point charge, because we have to consider a point charge everywhere. We are using this term point charge. What is a point charge? Point charge has a location, okay, a dot. It has only a location, but it is not having any dimensions, you know, either a round or a square or rectangle. Likewise, it doesn't have any specific dimension. A simple dot will indicate a point charge. Okay. With this background, let us try to define what is electric field intensity. Electric field intensity, before, in order to do that, we have to know this. An electric charge, it always set up an electric field in its surroundings, right? If there is one charge present in a space, surrounding that charge, certain field gets set up, right? It is just like if you put an ice cube, surrounding that ice cube, some temperature, lower temperature is felt, something like that. If there is a charge in the space, surrounding that charge, field will be experienced. Okay. So whenever there is an electric charge put in the space, surrounding that charge, field is set up. Okay. And if some other charge arrives in that particular field, in that surrounding, if some other charge comes, even that new charge will experience a force. Why? Because already there exists one charge in that surroundings. If one more charge is kept, if it arrives in that ambience, in that environment of the field, it will experience a force. Okay. This force, it is stronger when the intensity of this field, whatever the field is created in the surrounding, if that is very much higher, then the force exerted will also be higher. It is more stronger. So both are directly proportional. Okay. The field and the force, they are directly proportional. So how can we define electric field? Electric field intensity at any point, it is the field, it is an electric field. At any point in an electric field, it is the force experienced by a unit positive charge placed at that point. That is, suppose you have a charge, point charge, and we know that whenever there exists a charge, surrounding that some field will be set up. Okay, some field will be set up. And if I take one more charge here, we suppose we call it a test charge. Okay, charge under test, just for testing whether the field is present or not. So a test charge is put in this particular field, then there exists a force. This charge will experience a force. So that force experienced by this test charge, which is placed in that field, is called electric field intensity, denoted as capital E. I hope you understood the definition. If there exists a charge, say Q, surrounding that Q, certain field is set up. If I take one more charge for testing, say Qt, in that surrounding field, okay, inside that, then there exists certain force. So whatever force this charge will experience due to the presence of this charge and the field, we call it electric field intensity. Okay, please try to understand the definition. In order to find the equation, just like how we did for Coulomb's law, here we will try to find the equation for electric field intensity. For that, what we will do, let us consider a charge Q located at point A. Okay, at point A, we are considering a charge Q. Don't directly look into this picture. We will go one by one. Okay, what I am depicting and what I am marking on the screen, observe it. So whenever, well, let us consider a charge located at point A. I'm talking about this now. Let us assume that till the point B, the field is set up. Means this line, what I'm telling, this point B, assume that this is the surrounding under which there exists certain field. Okay. And remember, I'm just giving an example. Let us assume that certain circle is set up. That circle indicates the field till this point. Okay. You can even consider this line, whatever. I am taking one horizontal line. Till point B, the field is experienced. Okay. This point and this point is over. I'm just showing you this circle indicating the field, presence of field. It is required to find the electric field intensity. We have to find the electric field intensity. So for that, what we will do, we will take one test charge and we will put it at point B. We will place it at point B just to check whether the field is existing or not. It exists, but we have to confirm whether it is existing or not. For that, a test charge is put in at the point B, and let R is the distance between these 2 points. Okay, this is about the figure and the considerations. Now, as per the Coulomb's law, we have already seen what is Coulomb's law. F equals to 1 by 4 pi epsilon naught. If two charges are there, Q1 and Q2, we will write it as Q1 into Q2, Q1 into Q2 divided by the distance between those two charges. That is the force as per the Coulomb's law. But in our considered case, one charge is Q, the other charge is Qt. T indicates test charge. So I will change the Coulomb's law as per my requirement. Q into Qt divided by the distance considered is R. So R square. This is Coulomb's law for our figure. Okay. Now, if this test charge which I have taken in that premises, if it is a unit positive charge, that is the magnitude is 1 unit positive charge, then your equation will become what? 1 by 4 pi epsilon naught Q divided by R square, and this is called electric field intensity. That is what I have done here. Here you can see it. Force is equal to this. Okay, what I will do to this equation, let me show you. F divided by, I will make it Qt. What your equation will be? 1 divided by 4 pi epsilon naught, as it is, charge Q, and Qt I have taken to the denominator on the force side, divided by R square. So this Qt I have taken unit positive charge, which is equal to 1. So you will get F is equal to this 1 by 4 pi epsilon naught as it is. You will get Q by R square. So F by Qt will become F by 1. Okay, that's what is written here. 1 by 4 pi epsilon naught Q by R square. This we call it electric field intensity. So what is electric field intensity? E. E is equal to only this much. One more charge Qt is there. That Qt is equal to 1. Okay. Under that condition, force will become electric field. That's what is equated here. You can observe. I'll show you. E is equal to F when the test charge considered is equal to 1. Qt is equal to 1. Okay. Now, as I told you, electric field is a vector quantity. So the direction is very important. How to fix the direction of E? Just like the force, what we did in the previous session. If I consider a r cap as the unit vector along the line joining AB, this along the line joining AB, if I consider a suffix r cap as the unit vector, if I know this direction of unit vector, then direction of electric field intensity is in the same. Whatever AR direction, the same direction for E. So how to find AR direction? That is important. How to confirm the direction? If the charge considered Q at point A, this point, whatever charge is considered here, if that charge is negative, if it's a negative charge, then the direction of a force will be from B to A. That is, if this is a negative charge, so B to A, this will be your AR direction and force direction. Okay. This is very much evident because as per the conventions what we have taken, if the charge considered is positive, the field lines will be diverging, right? And if you consider a negative charge, you will get converging. So check, if it is negative, it will converge. The line will come like this. So remember that. Okay. Just to remember, I'm telling you. Positive means diverge, negative means converge. So if you consider Q as negative, try to put converge direction coming into. That will be your direction of AR. So if AR direction is in this way, so even field direction will also be, and force direction will also be in the same way, coming like that. Not outward, inward. Okay, coming into. So if Q is negative, direction of force will be from B to A, and this will also be in the same direction. That's what I showed you here. If Q is negative, this will be the direction of AR. Okay. And otherwise, if Q is positive, the other case, or divergent, force is acting outwards from the Q. Outwards means if a Q considered is positive, outward, coming out from A, point A. So AR direction will also be outward. This is how we fix the electric field intensity's unit vector direction. Okay, this is about the field equation, field definition, and how to decide the direction of this unit vector and the field. Any doubts till this? I hope you understood the definition. In short, what we write, what is electric field intensity? It is force per unit charge. Remember, F by Qt equals to E. And Qt, if you equate it to 1, F is equal to E. And F, you already know the formula, 1 by 4 pi epsilon naught. Q1, Q2 divided by R square. Q2 is Qt. Qt is equal to 1. If no doubts, I'll further continue. Any doubts? Any doubts till now? We have seen the definition of electric field intensity. We have tried to understand how to find out the equation for electric field intensity and how to fix the direction. Okay. So let me continue. As just now we have confirmed the direction, depending on whether the charge is negative or positive, the direction of E or F will be accordingly. Okay. So considering that direction also, E will be finally 1 by 4 pi epsilon naught charge by R square into the direction is important, AR cap. This equation, what I have written here, final equation, it is called the electric field at a point due to a point charge. This is, we have found the equation for electric field intensity at some point due to a point charge, due to the charge q and the presence of test charge, we have found out the electric field intensity. Sometimes, just to confuse you, the question will be, find the expression for electric field intensity at a point due to a point charge. So you will not be knowing which equation to derive. So this is the equation. So remember, this is the question expressed. Okay. Now, as a note, you can just glance this. Suppose that r, small r, what it has in the denominator, this small r, that too this r, okay, this small r, if it is in three different coordinates, x ax plus y ay plus z az, x y z are the magnitudes, ax ay az are the three different directions. Okay, if that is the case, then we have just now derived, we have arrived at this equation just now. E equals to 1 by 4 pi epsilon naught q by r square into ar. Okay. Here we will substitute this r square. R is this, we will try to substitute. 1 by 4 pi epsilon naught as it is, charge q is as it is, divided by this r is actually your distance, position vector, r's square, that is magnitude square. Denominator is indicating the magnitude, it is not a vector, okay, it is magnitude. Magnitude of this r, what is magnitude of this? It is square root of x direction square, y direction square plus z direction square. So this is your position vector's magnitude. So magnitude square into AR. What is AR? This position vector divided by its magnitude. So position vector I have written as it is, divided by the magnitude. In the next step, I have simply rearranged this square and square root gets cancelled. I have written the denominator and remaining as it is. In the next step, you can extend this to one more step. Just you can split this x divided by this into ax plus y divided by, individually you can write ax plus ay plus az, or else you can stop it. This is one just example I am showing you. This will be helpful to you while solving the problems. Understanding of this. Okay. Now this is important. Whatever electric field intensity equation we have derived just now, this, okay, 1 by 4 pi epsilon naught q by some distance square into AR, this how to represent in vector form, that is important. So let us see that. Okay, so I hope you understood this figure first. In order to represent your field in the vector form, understanding of this figure is very important. This is charge q, surrounding that charge certain field is set up. Because the field is set up at some point p here, I want to check what is the value of the electric field intensity. And if I check here, say S point or say R point, all these fields values will be different. Hence, it is called what? Vector field. Because vector field is such a quantity wherein that vector value, that is electric field value, it is not same throughout. Field surrounding में setup हुआ है, it doesn't mean that throughout the field is same. No, it is not. The value will be different at different points. This we have to remember. Now let us try to express the electric field intensity in terms of vectors, vector form. I hope you understood this figure first. You check from origin, drag a line to the point Q. From origin, drag a line to point P, because both are important for us. This is the charge kept. This is the point where field is to be calculated. And between these two lines, this is R, capital R, a position vector. This is R dash and R. You can take any notations, no issues. Okay. Now with this, let us try. 1 by 4 pi epsilon naught I have written as it is. Q is as it is in the numerator. Here it is the denominator r square, this position vector square. How to find the position vector? Using the vector addition, I have written here, you can check it. Position vector, check the directions. Okay, from origin these two are splitted. So from this end, take it to this continuity in the triangle. Then two directions are in the continuity. The third direction is different. R dash plus R is equal to small r. R dash plus R is equal to small r, or capital R is equal to R minus R dash. I have substituted that, same thing. Okay. This is about the R magnitude, its magnitude square. And what is AR cap? Whatever this position vector capital R is there, that value divided by its magnitude. Whenever you want to calculate the unit vector, a vector divided by its magnitude. Further, this is as it is, this is as it is. Denominator, check it, the powers, this is 2 plus 1 will be cube, and this same. This you discard it, okay? I think sometimes it's very confusing. Instead of taking R1, I have taken R dash, or R dash and R1, right? I think this should be taken dash, okay? Please change it. So I hope you understood this. This is the vector. Further, you can you leave it here itself, or you can continue one more line. What is the continuation check? This remaining all I have written as it is here outside. Now, instead of writing this, I have taken the positions, both x, y, z and x dash, y dash, z dash. I have calculated this distance vector r. This r minus r dash is equal to what? The distance vector. How to find out that? You can get it. The previous background I have shown you. You get this vector, take r minus r dash. How to find this vector? It is this value minus origin value is 0, 0, 0. It is x dash minus 0, y dash minus 0, z dash minus 0. It is this vector. Similarly, here what is this vector? X minus 0, y minus 0, z minus 0. So what is your r dash equals to? R dash is equals to x dash ax plus y dash ay plus z dash az. This is about r dash. Similarly, if you calculate for this r, it is x minus 0. So it is x ax plus y ay plus z az. Okay, these two vectors, r dash and r. This is r. Okay, once you calculate, subtract them. If you subtract r minus r dash, r is this, the lower value, r dash is this. X minus x dash ax, that's what I have written here. X minus x dash ax, y minus y dash ay, z minus z dash az in the numerator. Denominator, whatever this numerator is there, its magnitude, right? R minus r dash, whatever numerator you have written, its magnitude. See, this is the magnitude cube. So magnitude, if you take, it is, let me show you here. The magnitude is this, this and this. Take the squares of those, right? All these squares, and in square root. This square root I have covered it here. 3 into 1 by 2. 1 by 2 indicates the square root. So you can either stop it here itself, or in turn put these two by calculating these two distance vectors, r dash and r. Please remember, just change these, okay? I have taken r1, which is confusing. I have to correct it. It will be r dash. So I hope you understood this vector form of electric field intensity. If you have any doubts, please let me know. And please check what is the time. Please let me know till this any doubts you have. Till electric field intensity, we have covered the definition, how to find the electric field intensity equation, how to find the direction for unit vector, and the vector form of electric field intensity. 3 minutes left. Okay. Please, if you have any doubts till now, I hope you understood this. How to find r minus r dash. It is these two position vectors. First you find the distance of these two, then find the distance of these two and subtract. You will get the numerator. Numerators, magnitude, you have to write it in the denominator. Denominator power is 3. Actually, it is square root of this. This square root is nothing but actually 1 by 2. So that 1 by 2, I have covered it here, 3 by 2 as a whole, the power. No doubts till now? That unit vector AR is how to take. Okay, fine. How to take the AR. Unit vector in general, please go through the previous session. Let me go back and show you how to find the unit vector. That's what the basics should be good. How I have calculated, see, this is some vector given to you. How you have found the unit vector? That vector, see here, that vector given divided by its magnitude. Magnitude is 2 square plus 3 square plus 1. If any vector is there, that vector will be in the numerator, its magnitude will be in the denominator. So just like coming to your electric field intensity position vectors, let's see how we have found the unit vectors. Check. If you find these two lines, position vectors, use the distance formula, you will get this. Okay. If this is your vector given, then, sorry, you want this, right? So, this is your position vector r, which is equal to r minus r dash. So, what will be the unit vector? Unit vector will be the vector divided by its magnitude, r minus r dash. That's what I have substituted here. So, any unit vector will be the position vector, whatever the position vector is there, that